Welcome to another enlightening episode of Lengua Viva Cultural Insights, hosted by the ever-curious John Parker and the insightful Amanda Mitchell. Today's episode promises to be a captivating journey through the intricate history of our understanding of language neuroscience. Join John and Amanda as they unravel these monumental milestones in the field of language neuroscience. Remember to support Lengua Viva Cultural Insights by joining their Patreon community, where you can access exclusive comprehension exercises, vocabulary lists, infographics related to each topic, and transcripts to enhance your listening comprehension.
Hey everyone, and welcome to another deep dive. Ever feel like your brain is doing a million things at once just to understand a simple sentence?
Totally.
Well, today we're kind of cracking open the control panel of language.
Ooh, I like that.
We're going to explore the world of neurolinguistics. You know, how those different parts of your brain work together to make communication possible.
And get this, we're actually starting our journey like way back in the 19th century.
Oh, wow. Okay.
A time when, doctors, they literally thought that bumps on your head held like all the secrets to your personality.
Wait, seriously, they were feeling for like language centers on people's skulls?
Yeah.
Okay, well, that sounds a little wacky now.
Yeah.
But wasn't there like a method to the madness?
I'm talking about phrenology, right?
Yeah.
And believe it or not, it sparked a really important debate. I mean, their methods were totally flawed, but those early brain enthusiasts were onto something.
Ugh.
With the idea that, different parts of the brain might have specific jobs.
Okay, so like different apps on your phone have different functions. They thought different parts of the brain might be responsible for different things like language, memory,
Yeah.
even like your love for pineapple on pizza.
Exactly. Now, imagine being a doctor back then, and you're convinced of this idea, right?
Yeah.
And then you come across this patient who could only say one word, tan.
Okay, so that's where our friend Tan comes in, right?
Yeah.
This one case, it totally revolutionized our understanding of language in the brain.
Absolutely. Louis Le Borgne, or Tan, as he became known, he could understand everything people said, but his own speech was limited to that single syllable.
Oh man, that's going to be so frustrating. It's like having a brilliant thought stuck in your head with like no way to express it.
Totally, yeah.
Okay, so Tan could understand language, but he couldn't really speak it. What was going on in his brain?
Well, enter Paul Broca,
Okay.
this French physician who meticulously studied Le Borgne's case.
Right.
When Le Borgne passed away, Broca performed an autopsy, and he discovered a lesion, basically an area of damage, in the left frontal lobe of his brain. And that damaged area became known as, you guessed it, Broca's area.
Ah, so that's how Broca's area got its name.
Yep.
But it's more than just a name on a brain chart, right? What does that area actually do?
Well, here's where it gets really interesting. See, Broca, he found similar damage in other patients who struggled to speak. They could understand language just fine, but their speech was severely impaired, just like Le Borgne.
Okay.
And this was huge. It was some of the first concrete evidence that specific areas of the brain were actually responsible for specific functions.
Wow. So damage to Broca's area is like hitting the mute button on your ability to speak fluently,
Yeah.
even though your brain still understands language.
Right, guys.
It really highlights how localized functions in the brain can be.
You got it. And this was a total turning point. Broca's work, it really solidified this idea of localization of function in the brain. And it opened the floodgates for researchers to hunt for other language centers.
Okay, but the brain is rarely that simple, right? It's not like our brains just have a single button for language and another one for, say, doing your taxes.
You're absolutely right. Just as researchers were getting comfortable with this idea of Broca's area, they stumbled upon another intriguing language disorder. One that kind of flipped the script on Broca's findings.
Oh, I love a good plot twist. This is where things start to get really interesting, isn't it?
It does, yeah.
Tell me more.
Remember how with Broca's aphasia, it was like all about struggling to find the right words?
Right.
Even though you can totally understand what someone's saying to you?
Yeah.
Well, imagine the opposite. So you can speak fluently, your grammar's perfect, but the words you're stringing together,
Yeah.
they don't make any sense.
Whoa, that's like, what? Like writing a perfectly grammatically correct email that just descends into utter gibberish?
Yes.
What is going on there?
That is a great way to put it. You've just described Wernicke's aphasia,
Okay.
named after Karl Wernicke. He was a German neurologist who was, hot on the trail of all these language mysteries.
Right.
And he started noticing these patients who had no trouble speaking, but they just couldn't seem to grasp the meaning of conversations or follow simple instructions.
So like their brains were churning out words, but the meaning wasn't connecting.
Yeah.
Oh, that's so bizarre. So that must mean that there's another area besides Broca's area that's crucial for language.
Exactly. Wernicke discovered that these patients often had damage to a totally different part of the brain, a region in the left hemisphere towards the back, where the temporal and parietal lobes meet.
Okay.
And this area became known as Wernicke's area.
Okay.
And it's all about understanding the meaning of language,
Yeah.
both spoken and written.
So we've got Broca's area in the front. It's handling the mechanics of speech production.
Exactly.
And then we've got Wernicke's area in the back, acting as the brain's interpretation center.
Yeah, like a 1-2 punch.
Okay, that makes sense. But I have a feeling this is where the story gets even more interesting.
It does.
Because it can't just be two separate areas just working independently, right?
We're catching on quickly. It's like having a brilliant engineer who can, like, design these amazing cars,
Okay.
but they can't drive.
Right.
And then you've got this amazing skilled driver, but they can't tell you a thing about the engine.
Right.
They need to be able to communicate, right?
Okay, yeah, that's a fantastic analogy. So our brains must have some way of connecting those two areas, like the meaning maker and the speech producer,
Yes.
so they can work together seamlessly.
And you are absolutely right.
Okay.
There's a fascinating type of aphasia that really highlights this connection, conduction aphasia.
Okay.
So imagine being able to understand what you hear.
Mm-hmm.
You can speak relatively fluently,
Okay.
but when someone asks you to repeat a simple phrase,
Uh-huh.
you just can't do it.
That's so specific. It's like, I don't know, having all the ingredients for a cake,
Yeah.
but not knowing how to combine them. What's the missing link in the brain?
It all comes down to communication between Broca's and Wernicke's areas. And what often gets disrupted is this bundle of nerve fibers that acts like a bridge between them. It's called the arcuate fasciculus.
The arcuate fasciculus. Arcuate fasciculus.
Okay, so that's the brain's version of like a high-speed information highway, ensuring that the meaning processed by Wernicke's area reaches Broca's area for, smooth and coherent speech.
You nailed it. And when that highway is under construction, so to speak, it leads to those specific repetition difficulties we see in conduction aphasia.
Wow.
It's like trying to, relay a message when the phone lines are down. The message itself is fine. The speaker and listener are both capable.
Yeah.
But the transmission gets all garbled. That makes sense. Okay, so we've gone from bumps on the head to realizing that language involves not just these, specific areas, but also the connections between them.
Yes.
But we're not done with TAN just yet, are we?
Not quite, no.
There was something about the original research being challenged, right?
Yeah, you have good memory.
You see, with all the advances in neuroimaging, researchers were able to take a fresh look at Libornia's brain. It's been preserved.
Wow.
And they found that the damage was more extensive than Broca had originally realized.
Wait, so even after all these years, we're still learning from TAN. That's amazing. What did they find?
Well, it turns out that in addition to that lesion in Broca's area, TAN also had damage to another really crucial pathway.
Okay.
The superior longitudinal fasciculus, or SLF for short.
The SLF. Okay.
Think of it as another major highway. But this one runs from the front of the brain all the way to the back, connecting different regions involved in language and other cognitive processes.
So it's like discovering that the reason your GPS isn't working might not just be, a faulty speaker. It could be a problem with the antenna.
Exactly.
Or like the software that connects to the satellites. Like everything is interconnected.
Everything is interconnected. And this brings us to a really important point. While we've been talking about, specific brain regions like Broca's and Wernicke's areas,
Right.
it's crucial to remember that they don't operate in isolation.
Right.
They're part of this complex and interconnected network.
Yeah.
And damage to those connections can be just as disruptive as damage to the areas themselves.
This is already blowing my mind. And we're only just scratching the surface.
Yeah.
So we've got this interconnected web of brain regions all working together to make language happen. What's next on our language adventure?
Well, get ready to dive even deeper, because now we're going to talk about a model of language processing that completely changed the game. The dual stream model.
Dual stream model. Okay, you've definitely piqued my curiosity. Tell me everything. Dual stream model. It's like our brains have their own superhighways dedicated to language.
You're getting close. Imagine you're at a bustling party. You're chatting with a friend, there's music playing, people laughing, glasses clinking.
I can picture it.
Just like a whole sensory symphony just bombarding your brain.
Yeah, it's like trying to have a conversation while also processing a million other things. Kind of like what our brains are doing with language all the time.
Precisely. The dual stream model basically says that while you're busy chatting with your friend, your brain is actually processing that language along two parallel paths.
Okay.
Or streams.
Okay.
It's like having two sets of ears, each tuned to a different aspect of the conversation.
Okay, 2 sets of ears, 2 streams of information. This is fascinating. What's happening in each stream?
Okay, so let's start with, let's call it the content crew.
Okay.
This is your ventral stream.
Okay.
And its main job is to make sense of what your friend is actually saying. So it's analyzing the meaning of their words, deciphering their tone, figuring out the emotions behind their words,
Wow.
basically getting to the heart of their message.
Okay, so that's the content crew, making sure I understand what my friend is actually saying.
Yes.
What about the other stream? What are they up to?
That is where the language logistics team comes in.
The language logistics team.
Oh, think of this as your dorsal stream, and it's all about the how of language. It's busy analyzing the sounds of your friend's voice, figuring out the grammar of their sentences, and even like predicting what they might say next.
So while I'm trying to follow the story my friend is telling in one ear,
Yeah.
the other ear is making sure I'm keeping up with the pronunciation and the grammar and the flow of their speech. It's like multitasking on a whole new level.
That is a great way to put it. And here's the really cool part.
Yeah.
Brain imaging studies. They've actually shown these two streams in action.
Wow.
They involve these distinct networks of brain regions, all working in concert to make language happen.
It's like watching a perfectly choreographed dance inside the brain.
Yes.
So which parts of the brain are involved in this linguistic two-step?
Well, the ventral stream, our content crew,
Yeah.
they rely heavily on areas in the temporal lobe. That's the part of your brain that sits right above your ears.
Okay.
And this makes sense because the temporal lobe is also a key player in, memory and auditory processing.
So it's tapping into our memory banks and helping us connect the words that we're hearing to what we already know about the world.
Exactly.
Okay. What about the language logistics team? Where are they headquartered?
The dorsal stream, that lights up areas in the parietal and the frontal lobes. So the parietal lobe, which sits kind of towards the back of your head, that's all about spatial awareness and integrating information from your different senses. And the frontal lobe, as we've already discussed, that's where you find, Broca's area and those other areas involved in planning and executing speech.
Wait a minute. So our ability to produce speech is actually tied to this dorsal stream?
Yes.
This language logistics team?
Yes.
That's figuring out how to put those words together in a way that makes sense.
Exactly. It highlights just how interconnected all of these processes are. It's not just about understanding the meaning of words. It's also about coordinating, all the intricate movements of your mouth and your tongue to actually produce those words.
Wow. This whole journey has been incredible. We've gone from feeling for bumps on skulls to mapping these intricate highways of information flow inside our brains.
I know. It's amazing, isn't it?
It's truly amazing how something as complex as language emerges from this messy, interconnected organ.
And here's the thing.
Yeah.
We're still just scratching the surface. Every new study, every new discovery, it brings us one step closer to unlocking the full potential of the human brain and understanding just how it pulls off this incredible feat of language.
It makes you appreciate the simple act of communication in a whole new light.
Totally.
So next time you're, having a conversation, take a moment to marvel at, this incredible orchestra of brain regions that are working in perfect harmony to make it happen.
Absolutely. And who knows, maybe one day we'll unlock the secrets to, even more efficient communication, maybe even understanding entire languages with a simple brain scan. But until then,
Right.
Keep those conversations flowing, keep those brains buzzing, and never stop exploring the fascinating world, within and around you.
You heard it here first, folks. Thanks for joining us this deep dive into the brain's language centers. See you next time.
Words that flow like rivers do. Learn a language, join the crew. Every lesson something new. Lengua Viva here for you.
Grammar rules and vocab tight. Practice every day and night. Conversations feeling right. Change your world with words so bright.
Lengua Viva, take a chance.